that's passing through 1 comma 8 and 6 comma 2. So A is my 1 comma 8 and B is my 6 comma 2. Determine its direction vector. So what's a direction vector? Well, a direction vector essentially is the slope of the line. How do I get from A to B? What do I need to do to get from A to B? And so if I were to look at the slope of this line, how would I get from A to B? I would go from 8 to 2, which means I'm going to move down 6 units. And then I'm going to move to the right 5 units. Yes, I'm giving the magnitudes of these line segments. Okay, so in terms of a direction vector, so if this was a slope, how would we write this? Slope of this line, how would I write this?
-6/5.
Yes, always rise over run, and we see that it's a negative slope, so it's -6/5. As a direction vector, what you're doing is you're subtracting your components, which really is essentially the same thing we do for slope, right? We subtract our x values and our y values, right? It's always y over x. And now we're writing it in component form. So which value has to go first? Look at your slope. Slope is equal to rise over run. Rise represents our vertical axis. It represents y. So it has to come second. First, we need 5. Now, does it matter where the negative goes? No, it's a slope, right? So we know that -6/5 is the same as 6/-5. Now, following the math that I've done here, I've got my negative here. However, I could have subtracted the other way, and I would get the exact same answer, just my negative would be with my y component rather than my x component, and it makes no difference. These are called direction vectors. Oh my goodness, guys, I lost connection and I didn't realize, and I was literally teaching to nobody. How far did we get here? Did you guys hear any of the lesson?
Only like the beginning part where you're talking
Oh,
about the slope from A to B.
oh,
Yeah, like
you
2
gotta
minutes.
be kidding me. All right, we're gonna do it again. Oh, I'm sharing my screen, so there's no way of me seeing that I lost my connection because the Meet tab is still there. But anyways, okay, we're gonna try again. Hopefully this doesn't happen again. Oh boy. All right, so let's do that again. All right, so we have this line, excuse me, and it passes through the points P and P naught. Okay, and is parallel to direction vector M. Okay, so the vector M is our direction vector. So this is how we define the vector equation of this line. R naught is the position vector. So that's a specific point on our line. Okay, so that's getting us up onto this line. That position vector is what gets us onto the line. Then I need a direction vector added to it to get my resultant R. Okay, so I need a direction vector that is parallel to this line because it's got a line on the line. So then I can find the resultant R. And that's how we define the line. So notice here, M is a vector parallel to the line and called the direction vector of the line. T is a real number or parameter. Okay, you're going to hear that a lot. It just means it's a scalar. Okay, so a parameter. Note the vector equation of a line is not unique. It depends on the specific point P naught and on the direction vector M that are used. So let's talk about that. What does this mean? When I say that this vector equation is not unique, what does it mean?
Means you can have many other ones.
Good. So this is not the only way that we can define this line. I can define this line in an infinite number of other ways. And the reason is there's an infinite number of points on this line. So I can define this line starting at any point. And as long as I use a direction vector, I'm still going to be on the line. Like if I have a line, so even think about when we draw lines. Hold on. So think about when we draw lines. So if I give you 2 points, or if I give you a point and a slope, even better. So I give you a point and I tell you that the slope of this line, so let's say I give you the point 1, 1. And then I tell you that the slope of this line is 3/2. So I know that I need to rise 3 and run 2. And I get another point on my line. But then I can repeat this slope again to get another point on the line. I can go up 3 again and over 2. And this is like moving from here and just multiplying this by 2. And that's what we're doing here. That's why it's okay to multiply by t. You're still going to end up on the same line if you do that slope 3 times or 4 times or -7 times, because I could also go back, right? I can do it negative. I can go down 3, so that's -3, and then back 2. So I've got my double negative there, and I'm still on that line. Do you guys see that? So now I want to define this line. Well, I can define this line starting at any point. I can start it here, I can start it here, start it here. I can start it at any point on this line. And that's why our vector equation of a line is not unique. Okay? Okay, good. So using components, the vector equation of a straight line is you get any point on the line, x naught, y naught. That's your point. Any point that's on the line can be used here. It is your position vector. And then we need to add a direction vector. Okay, and that direction vector can be multiplied by any t, any number. Okay, any value of t, it can be multiplied by, and you're still going to end up on that line. So it's okay. Now, another way to show a line are using parametric equations. And parametric equations is when you solve for your components x and y. So basically, this vector r as components, we can just say is x comma y. And so here now, I'm saying x is equal to x naught plus t times a, y is equal to y naught plus t times b. And these are called parametric equations. It's just another way of writing an equation of a line. a vector equation of a line. Are there any questions? Okay, good. Excellent. Okay, so example 2. Find the vector equation of the line passing through this point and having a direction vector of 3, 2. So again, guys, this is just the slope. So if I had to write this as a fraction, how would I write this? Would it be 3 over 2?
2 over 3.
Yes, excellent. Right? We know it's rise over run, y over x. So 2 over 3. Good. Find 2 other points on the line. Okay, so first of all, I want to define this line. I want a vector equation of this line. So I take the point. That's my position vector right there. And then I can multiply by any multiple of t. And I use my direction vector. And I just say t is an element of real numbers. Okay? That's your vector equation. Okay, so now we have to find 2 other points on the line. How can I find 2 other points on the line?
Miss,
Yeah.
would there be a restriction that t can't equal 0, or is that okay?
Yeah, no, t cannot equal 0. Because t cannot equal 0, ever. Why? Why can't t equal 0?
Because it'll be the 0 vector if it's 0.
Yeah, that's right. You're just going to get 0, and 0 is not going to get you on, is not going to get to another point on that line. Okay, so t can never equal 0. Okay, sometimes we define it, but so you could say t cannot equal 0. However, we don't do this every single time. So we do this in this lesson because just to understand that t does not equal 0, but then we don't carry this through in the other lessons. And so that's why I sort of eliminated it from this one. Because then the students get confused. Well, how come we wrote it in the first one and we don't write it anywhere else? Okay, but yes, t can never ever equal 0. All right, so to find 2 other points on the line, what am I going to do? And I want you to help you answer this question. I want you to think of this. So I have 1 point on the line. How do I find another one? How do I find another one? So what do you guys think? Okay, so I have a point.
Plug in random numbers for t.
Yeah, plug in a random number for t, because that's just going to give me a multiple. So if I have from my vector equation, let's say t is 1, right? And I'm starting here, then I get this guy. But then if t is 2, I get this guy. And if t is 3, I'm going to get the next guy, and so on and so forth, okay? So you just have to choose any random number for t. So to find 2 other points on the line, sub in values for t and solve. All right, so values of t. So I'm just going to follow what I have here. Let's say t is equal to 1. So if t is equal to 1, then I have negative 1 plus 1 times 3, 2. Oopsies. And so I'm just going to have negative 1 plus 3 and 1 plus 2. That's another point on the line. Okay, give me another value of t. Any value of t.
4.
Sorry?
4.
Sure. I'm going to say negative 4. And now, okay, and we just have to see what this equals. So it's going to be negative 1 minus 12. And here it's going to be 1 minus 8. Cool? And that's how you find points on the line. And of course, I can do this infinitely many times. Are there any questions? Okay. All right, example 3. Determine the parametric equations of the line and the vector equation of the line that passes through the point P 1, 4 and Q -2, -6. So I have 2 points on my line. Does the point -5, -16 lie on this line? Okay, so I have 2 points on my line. Go back to grade 9. You have 2 points on the line. What can you figure out?
Slope.
You can find the slope, and that's exactly what we're going to do here. But we just call it a direction vector. So we're going to find the direction vector PQ. You could also find the direction vector QP. It really doesn't matter. I decided to do PQ, so I must start with -2, -6. Make sure that what you're writing is true, right? And so I'm left with -3, -10. That is my direction vector. Now, just like with slopes, so if I find a slope and I had -3 or -10 over -3, what would I do with that slope? Would I use -10 over -3? I wouldn't. I would say 2 negatives make a positive, right? So I'm going to use 3, 10. Now, you can use either, right? Same slope. But I'm going to use the positive. So now, what's my vector equation? Well, I can choose whatever point I want. Both of these points lie on the line, so it doesn't matter which one I choose. Which one do you guys want me to choose? Do you guys want 1, 4 or -2, -6?
1, 4.
Sure. Where t is an element of real numbers. Okay? And make a note, please, that you can choose either point. Okay, doesn't matter. They both lie on the line. Okay, now I need parametric equations. So parametric equations means I want x equals and y equals. So it's going to be 1 plus 3t, y equals 4 plus 10t. Okay, just remember, just think of your vector r as components x, y. Are there any questions? Okay, well, I think the question also asked us to check, right? Does the point -5, -16 lie on this line? So how can I check? How can I check -5, oopsies, -5, -16?
Sub it in as R and see if T matches.
Yeah, exactly. We're going to sub it in and see if I get the same t value for both of these. If I get the same t value, then yes, it lies on the line. It satisfies the equation. Come on. So I have x equals 1 plus 3t. So now I have -5 equals 1 plus 3t, and I solve for t. So -6 equals 3t. And so t equals -2. And then I have y equals 4 plus 10t. My y is -16. -20 equals 10t. And I get t equals -2. So does the point lie on the line? It sure does. Are there any questions? So -5, -16, to get there, I would have to take this slope and multiply by a t of -2 from this point. Okay? Cool. All right. Example 4. Determine a vector equation of a line passing through the point 3, 1 and perpendicular to this line. And we have a vector equation of a line there. So perpendicular. Let's highlight perpendicular. What's that going to do for me?
The slope's reciprocal.
Good, excellent. We know that the slope has to be the reciprocal. So I'm going to show you a long way to do this, and then I'm going to show you a very simple way to do this. So if we're looking for a new direction vector that we know is perpendicular, well, if I have two vectors in component form, what if they're perpendicular, what do I know? What do I know about perpendicular vectors? Think about it. You guys there?
Dot product is equal to 0.
Yes, excellent. The dot product is equal to 0. So let the new direction vector be. And I'm just going to call it A comma B. Since we know that they have to be perpendicular, I can say that my two vectors dotted together, so M1 dotted with M2 has to equal 0. So A comma B dotted with 2 comma 1 equals 0. So dotting these, what do I get? Oh, you guys should know this. Yeah. 2A plus B equals 0. And then what I'm going to do is solve for B. So what I know now is, since M is equal to A comma B, I can say it's equal to A comma negative 2A. Now, this is a slope, right? It's a direction vector. It's a slope. So what do we always do with our slopes?
Reduce.
We simplify them. Yeah, we simplify them. So if I had to simplify this, I would divide out the A, yes? And there is my direction vector. Okay, that is perpendicular, 1 comma negative 2. Now, how else could I write this? Could I write this another way?
Negative 1 comma 2.
Yeah, because we know with slopes, it doesn't matter which is negative, your numerator or your denominator. We just always put it in the numerator because that's the form that we prefer. However, with components, it doesn't matter. Okay, now, did I have to do all this? Did I have to do all this work?
No.
No, because we learned in grade 9 that if you have a slope, this is showing me a slope of 1 over 2. And I want the perpendicular slope. What do I do?
Take the negative reciprocal.
You sure do. I take the negative reciprocal, which is negative 2 over 1. And now writing this as a component, it would be that, wouldn't it? Or negative 1 comma 2. So all I had to do here was look at this and take the negative reciprocal of that. Are there any questions? Okay, so just keep in mind, guys, you don't have to do all this. You can go straight to this. Okay? All right, so vector equation. Was that, yeah, determine a vector equation. Yes, we want to find the vector equation. So what's my vector equation then? Oh, I know somebody knows. What's my vector equation?
3, 1 plus T 1 comma negative 2.
Okay. 1 plus T. Did you, 1 negative 2 or negative 1 2? It doesn't matter. And we say T is an element of real numbers. Okay. So you could have gone straight to this. All right, so little summary. You have parallel lines. What do we know is true about parallel lines? Well, if you have a direction vector M1, it can equal a scalar multiple right? That means they're parallel. So if you have M1, you can take any scalar multiple, and it will be equal, right? Parallel lines. Perpendicular lines. If my first direction vector is A comma B, and the other one, my second direction vector, is perpendicular, well, now it's going to be the negative reciprocal, which happens to be negative B comma A. Cool? Okay, and as I said to you before, this is showing me a slope of B over A. This is showing me a slope of A over negative B, or negative A over B. Cool? Okay. That's it for this section. So you guys can take a little break. We'll take a little break. Maybe it's 1:02. So let's come back at 1:10. So 8 minutes. Stretch your legs, get a glass of water, do whatever you want to do. We'll be back at 1:10.